morning and a very warm welcome to Nokia SReXperts 2020. My name is Heidi Adams. I'm the head of IP and Optical Networks Marketing here at Nokia, and I'm going to be your host over the next 3 days. This year we're really excited to be delivering the conference in a whole new way, leveraging the networks that we have collectively built, the networks that keep us going. All of this is enabling us to bring to you a virtual conference event, enabling you to participate with us, whether you're in the regular office or whether you're in a home or remote office location. And of course, our Nokia speakers that you'll be hearing from over the next couple of days are also joining us from a variety of locations from Canada, the US, and even overseas. I'm actually coming to you today from Ottawa, Canada. Over the next 3 days, you'll have the opportunity to hear from our executives, our customers, and our subject matter experts. We're going to dig into some of the overall industry trends. We're also going to have the opportunity to dig in to some of the new technologies, innovations, solutions that we're bringing to you in the areas of IP routing, optical networking, and network automation. Before we get into today's plenary sessions, just a few housekeeping items. We really want to ensure that you have some familiarity with the platform and that you can take advantage of the event as much as possible. After our plenaries today, we're going to shift over into a series of breakout sessions. And in the breakout sessions, you'll have the opportunity to engage in some live Q&A with our subject matter experts. Following the breakout sessions, we will open our virtual demonstration hall, where much like in a regular demo hall, you have the opportunity to wander around, see different demos, and then engage with our demo experts to learn more about the solutions on offer. If you're interested in setting up a follow-up meeting with one of our demo experts, please just use the contact function in the demo booth itself. A really big part of SReXperts is the dialogue, the conversations, the opportunity to engage with Nokia colleagues and SMEs, and also with your peers and colleagues in industry. Of course, in a virtual event, we have to do this a little bit differently. One of the tools we're bringing to you as part of this session is called our social wall, and you can access this, again, going up to the menu function and clicking on social wall, and here we invite you to join in on some of the conversations over the next 3 days. If you're into social media, please use #SREXperts. As you go through the event, if at any time you require technical support or if you'd like to get further information on any of the logistics behind the event, again, go into the menu bar and click on Account, and here you'll have the opportunity to access the technical support area or contact event team option for more information. So with that, let's get to the main event. I'm very pleased to introduce our first speaker for the session today, Basil Alwyn, who's co-president of IP and Optical Networks here at Nokia. Basil?
Welcome to SReXperts, our 15th annual SReXperts, and unfortunately a virtual SReXperts. We very much like this particular forum to be face-to-face, not only because we appreciate the interaction, but also because we tend to have labs and different ways to interact. However, COVID-19 has changed everything, including our conference, so we've done a lot to try to preserve the best parts of SReXperts for you over the next 3 days, and I hope you'll take advantage of the work we put into it and the sessions we put together. As usual, we've tried to make sure they're technical with a lot of content, and we're hopeful that it's helpful to you as you go through the sessions over the next 3 days. I want to start by talking a little bit about the context that we find ourselves in. And I want to start with a discussion of kind of the last decade of what's happened in our networks and our service provider public infrastructure. I call it a self-reinforcing cycle, or a gain loop, you might refer to it as. And what I'm referring to is the building of access capacity and network capacity on the internet, and that in turn giving app developers new tools to rethink how they write applications and reimagine applications with better characteristics, whether it's a better front end or a better back end, better experience. As app developers do that, of course, customers like it. And as customers enjoy those applications, they use them more and more, and they put more pressure on the network. This cycle has been going on since, as I said, about a decade at least, and what has happened is we're slowly subsuming really everything into the digital on-demand world. So if you want to have your information wherever you want it, you want to watch your show, you want to enjoy your particular application anywhere, we can deliver it now. It's really impressive what's occurred. But the result is actually kind of difficult, or let's say interesting, for everyone who's building network infrastructures. There's pressure on all things network. Not only is there a demand for lower costs at all times and higher capacity, which we've, of course, always are focused on delivering together as a community, but also the demands on the network are going up, not down, in terms of reliability, in terms of security. So we find ourselves in a situation where the pressure from this virtuous cycle on the network infrastructure itself is really remarkable. And it requires all of us to continue to focus and innovate in order to deliver what customers really want. As if that weren't enough, COVID-19 arrives and changes everything. Not only did we compress an entire years of bandwidth growth into just 3 weeks, but some major shifts occurred from enterprise networks to consumer networks, exposing certain weaknesses in the infrastructure like peering points and data centers that needed to be addressed. At the same time that this was happening, certain applications came to the fore, most notably video conferencing, which experienced an explosion in adoption, has now cemented as fundamental to everything we do. At the same time, security is still a strong concern, and our Deepfield platform noted an increase in security events, including DDoS attacks, as this COVID-19 change occurred. So in summary, COVID-19 added to an already dynamic network evolution, and the answer is, as always, innovation. And when I talk about innovation, I'm not just talking about core technology innovation, which of course is our lifeblood. We're all talking about innovation across our business and across our community. Innovation in core technology, of course, but also innovation in tools and automation that are so important for operationally running our networks more efficiently and in a more agile way. Innovation also in our services teams around the world that help our customers deploy and keep the networks up and running as they become more and more important to society. Let me give you a few examples in each of these areas. In core technology, we continue to deliver at a breakneck pace new innovations. You might have seen our recent announcement of data center switching, which really fundamentally addresses automation and how to most efficiently run a data center infrastructure. You're going to hear a lot more about the data center platforms that we're rolling out in the upcoming sessions. In addition to the data center, which is a key area of focus, of course, we're also innovating in the platforms that we've traditionally delivered, including gateways. Gateways are becoming all important in positioning and where to place content in the network. And so we're doing a tremendous amount of work right now on allowing our gateways to be more flexible and also blur the distinction between fixed and wireless to make it easy for customers to deploy the edge of the network wherever it needs to be, including in a dynamic way. Again, you're going to hear quite a bit more during the sessions in the upcoming days on this. And finally, of course, we continue to innovate in silicon, which is so fundamental to make sure that we can deliver the right capabilities at the right price points and densities as we take advantage of the latest and greatest silicon technology. FP4 has been a tremendous success for us and our customers around the world, but of course, you can imagine what's coming next, and in 2021, there's going to be a tremendous amount of interesting innovation coming in this area of networking silicon from Nokia. Beyond traditional software and hardware innovation through the acquisition of Alinian earlier this year, we added a new foundational technology to our tool set, silicon photonics. Some mistake silicon photonics for silicon technology, but it's very, very different. In silicon technology, we're using the silicon substrate to transmit electrons, whereas with silicon photonics, we're actually using it as a waveguide for photons. So it's a wholly different skill set, a wholly different team, and you need a really deep understanding of how to use the technology appropriately. Silicon photonics is allowing us to shrink the optical transponder for certain distances to a pluggable module. As you can see on this slide, that module, that front end, that optical component is smaller than a penny, where it used to occupy quite a bit of board space and power. Beyond optical modules, we see SiPho as a tool for more comprehensive IP optical architectures into the future. We think this technology is going to allow us to continue to ride the cost and performance curve that customers are demanding of us well into the future. Beyond the focus on cost performance and functionality of our systems, automation has come into focus as a key enabler to running networks in a more agile and efficient way. With some years of effort, our NSP has evolved to a programmable platform with workflow management and intent-based networking support. Along with this, NSP now offers real-time analytics and assurance with closed-looped automation. It's a really big step forward for our NSP platform, and I think you'll enjoy hearing about it at the upcoming sessions. Interestingly, COVID-19 has pushed innovation even in how we deliver services globally. The stat you see on the right is real, a huge leap forward in remote configuration, servicing, and troubleshooting, and the tools we've had to develop to support these activities. This is actually a good trend as we develop better and more repeatable processes that minimize issues and mistakes. So as you can see, across core technology, automation and tools, and even service delivery, innovation is everywhere, and that has been the answer. And teams across our company and across the industry are delivering. Which brings me to a final point, which is how proud we are to be part of the global community that has kept the world going during this moment in history. It's truly hard to imagine this pandemic without our contribution, and that is a big statement. So a huge thank you to all of you for working with us over the years to build the global network, and maybe more importantly for the work we will do together now as all of society continues to look towards us. Networks really do keep us going. Enjoy the upcoming sessions, give us feedback, and hopefully look forward to seeing you again in 2021 face to face.
Hi everybody, I hope everyone is doing fine in these tough times. My name is Basil, and I'm responsible for the transport network in Do. I've been working in Do for over past 13 years. Like I said, I'm responsible for the transport network, so all the IP, optical and microwave within Do. COVID, as everyone knows, were interesting times for the full world, especially the telecom sector. I would say we had an interesting time also in the telecom sector with COVID. Initially, we went through the phase of everyone working from home, everyone studying from home, and that was challenging. That was very challenging in the initial days, especially a lot of the upgrades, a lot of the links. We had a lot of links additions that had to be done, a lot of upgrades that had to be done within Do to support the need of working from home or studying from home. There were some government initiatives which were supporting the general public, and which telcos also had to meet and provide for. So we really saw a shift in traffic. From the mobile traffic, there was a drop in the overall mobile traffic, and there was a spike in the fixed traffic. Our fixed traffic grew 30% on some cases to about 100%, 200% in some cases, depending on the application. Our BNGs had a spike of 40% to 50%. We had to add multiple 100 gigs on our BNG. We had to add multiple links with our OTT providers. Microsoft was a big, as they provide all the content and Microsoft Teams for the schools, which we used heavily in the UAE. So we had to add a lot of links with Microsoft. So they were interesting times, but they were challenging times also. We still had to continue with our business, and we still had to do our regular upgrades. We still had to do our maintenance, in addition to adding all these links. So they were still keep the services up and running, and you have to make sure that with everyone being at home, now there was no peak and off-peak hours because everyone's at home. Either they're working or they're studying, or they want to watch something on the internet. So that differentiation of peak and off-peak sort of got muddled, and there was no clear line between the two. So we had to also find different ways and different techniques of doing what we had to do, which was very interesting, and it opened new opportunities, and opportunities which can be solved with automation, which can be solved with having multiple services, having multiple pre-checks done in a more efficient manner, in a less time-consuming manner. So I would like to say that as telcos, we always focused on automation and providing new services. And I think we should take a step back and really build the foundation and lay the groundwork for automation and focus on how we can automate all of our network or infrastructure deployment. And that being IT infrastructure or telco cloud infrastructure or the routing, switching, optical infrastructure. Adding those or automating those would really add a lot of benefit. IT has been ahead of us in this game of automating customer services, and we are sort of lacking behind from a telco, from an infrastructure perspective or perspective in terms of all the automation we can do on our infrastructure. So COVID really emphasized on how important the infrastructure is and how important adding new links or doing software upgrades or downtime, and how they have to be optimized to meet all the requirements and the needs and the expectations, the growing expectations of the customer. So I would really like to take this opportunity and emphasize on how important automation is in a telco's infrastructure environment. So in our case, we're really working with Nokia, trying to really get the best out of NSP and see how NSP will support us. It's already doing it today. We are automating our pre-checks and post-checks with NSP and with some external automation with working with Nokia PS, where we reduced the pre-check time and post-check time from 8 hours to an hour and a half. So when you compare that with the overall situation, you see a drastic improvement in the time it takes to have an outage window or to have an unsatisfied customer. Just final thoughts. Let's really focus on building the foundation of the infrastructure and automate that before we go ahead with customer service automation and providing that extra services. Thank you very much.
With that, we're going to move on to the next presentation in our plenary session. I'd like to introduce Rudy Hobeka, Vice President of PLM for Mobile Packet Core and IP Routing. Rudy?
All right, hello. My name is Rudy Hobeka. I run product management for our IP and Packet Core portfolio. Welcome to this edition of SReXperts. I had imagined this event to be very different, of course, but given the COVID-19 situation, this is for sure the next best alternative. I hope you're all healthy and I hope you're all safe. And I do hope that we have the worst of this COVID-19 pandemic behind us now and that soon things will be back to normal. And I'm looking forward to meeting you all again face to face for next year's edition of SReXperts. Now, once this COVID pandemic is behind us, I think the world is going to remember a few things. One of the things it's going to remember is the importance of networking. Basically, during this COVID-19 period, it's the networks that all of you are building that kept the world going. You kept people connected, informed, entertained, and productive. It shouldn't be a surprise then that during the heat of the lockdown that we saw globally on average, enhanced mobile broadband traffic increased with about 20%, and fixed broadband traffic even increased 60% in some countries. It shows the importance of what we do. It shows the responsibility we have to society to keep people connected, billions of people connected with people they care about, and to keep them productive, of course. But I think more importantly, what the world is also going to remember is that what we're seeing now is giving us a glimpse of the future. A future where there is going to be more working from home, more education from home, healthcare from home. And as a result, networking is not only more important now than it was ever before, it will even increase in importance moving forward. And that's what keeps us motivated. That's why we keep on innovating to allow you to build your networks more cost effectively with more security and enhanced levels of automation. Now, the extraordinary events of 2020 have not slowed us down. We did a lot of innovations in our IP optical networking group. I'm going to talk about two pretty important ones. I'm going to talk about our entry into the data center market with SR Linux, our fabric services platform, and our data center hardware portfolio. And I'm going to talk about 5G, which is, of course, one of the major mega trends in our industry, and how we rounded out our 5G offering with a cloud-native containerized packet core deployment option. All right, let's dig in. First of all, some of you may have attended our launch event on July 9th, a virtual launch event where we basically entered the data center market with a new data center practice that we've created in the ION IP optical networking group. This is the result of a development we've done over a period of 2 years in stealth mode. And we believe that what we're bringing to market is a truly next generation data center solution. That was, by the way, co-developed with some of the big web scalers in the US. And I think that's very important. And it really gave us a unique opportunity to start a clean slate development in collaboration with people that have a lot of experience building these large-scale data centers. And that interaction allowed us to learn from how they build data centers, the challenges they are facing, and we've been able to bake all of these learnings into our data center portfolio. So we're obviously very excited that we're now taking this to market. Now, if you look at this slide talks about what we learned from engaging with those big web scalers. And what we learned is that they are facing a number of challenges. And these challenges can broadly be categorized across those 3 pillars that you see on the slide. First of all, they need more automation in order to keep pace. It shouldn't be a surprise. Those data center networks are growing in scale and in complexity, and same can be said for the workloads that run on top of them. So those web scalers need more automation. They need to basically evolve from mostly human-driven decision processes to autonomous operations. What we also learned as part of this pillar is that web scalers need the agility to implement changes on that fabric very frequently, because this is a very dynamic environment, but they need tools that help them manage the risk of change. The second pillar is all about openness in order to take back control. That was a key theme that we learned about during this engagement. Web scalers need the data center fabric to be open. They want to customize how that fabric integrates into their environment. They basically want to be able to develop and run their own applications on those switches. And that's already happening today in our initial deployments. Applications are run on those switches that help with troubleshooting. Some are pre-processing some of the data out of the routers, normalizing that, making it easier for operational systems to consume that data. And some web scalers are even developing their hardcore networking protocols. They basically want to run their own routing protocols on those switches. So the system needs to be open to allow all of that. As part of that pillar as well, feedback we got specifically from the operational side of those cloud builders is that they want to customize the way they interact with the systems. They basically want it to be able to customize the commands they use to configure systems, to troubleshoot systems, just to make their life a lot easier. And then the third pillar is, of course, all about scale and reliability. As those data center environments scale, become bigger, become more complex, you need a routing protocol stack that can keep pace. And that's a big challenge in current data center offerings for sure. That's what we designed towards. Basically, what we identified, as you see on this picture, is that there is a need for a third-generation data center solution. A third-generation solution that brings NetOps capabilities, which is openness and automation, to the next level, but has the strong foundation, the foundational capabilities that allows you to scale with reliability. And current generation data center solutions, whether it's generation 1 or generation 2, they clearly fall short from meeting those requirements. They are often proprietary and closed, hard to automate, and quite limited in scalability as well. Our design target was generation 3. I hope I can convince you that that is exactly what we've delivered to the market. Now, what you see on the slide is that we basically did a significant job here. What we brought to market is a whole data center practice. It's basically a full stack solution that includes new hardware, our 7250 IXR and 7220 IXR data center routers. It's a brand new network operating system called SRLinux that runs on top of those switches. And then we have our Fabric Services platform, which is a toolkit to automate operations in a data center environment. Let me now just zoom into some of those components and show you how we are different from current solutions on the market and why we call this a third generation data center solution. And let me start with SRLinux, the Nokia SRLinux. That's a brand new network operating system we designed specifically for data centers. And it's a third generation operating system. It is more scalable and reliable than what we've seen in the industry so far. A lot of focus on automation, of course, and a lot of focus on openness. This slide shows how we did this. First of all, what you see there is that SRLinux leverages SROS, our SRS routing protocol stack that you're all using in your networks today, decomposed in its individual networking applications, of course, that run as individual processes on a Linux-based operating system. Now, what that means is that we bring the reliability and the scalability of SROS in the data center. And that's really important, right? That addresses the requirement to deal with more complex and more scalable environments. Now, the way we bring automation to the next level is by making sure that we did a ground-up design of this operating system for model-driven management. Every application comes packaged with its own Yang models for configuration and state. And as a result, we have full visibility. We have full coverage for configuration and state. And because there are no translation layers, we have really high performance telemetry as well. And that's really key for next generation data centers because they rely on real-time data they get from switches to drive their decision process. The way we bring openness into this operating system is quite unique as well. And there's two aspects shown on this slide. First of all, there is our NDK or NetOps development kit. NDK is very unique. It allows you to develop your own applications or use third-party applications and run them as native citizens, as basically first-class citizens on our SR Linux operating system. What that means is that you can write your application, you package them with your own Yang models for configuration and state, and as soon as that application starts in SR Linux, you can use all the infrastructure services that SR Linux provides. That means you get immediately model-driven management using any of our northbound APIs like GNMI, and you also get streaming telemetry. All state published by your application becomes streamable using our streaming telemetry framework. You also get full access to our internal database, which means you have ultimate flexibility to customize this application to fit your environment. And last but not least, that NDK is also giving you a much better application development experience. It's basically an NDK that is based on protobufs. And that means, first of all, that you can choose the programming language that you like, because proto compilers exist in pretty much every programming language these days. And second of all, protobufs are inherently backward compatible, which means that the development of your application is now decoupled from the lifecycle of SR Linux. You get independent lifecycle management of your application. You don't need to recompile it every time you upgrade to the next release of SR Linux. So a much better experience for sure, a next level of openness, I would say. Just to highlight our focus on openness, we have even open sourced our CLI. Our CLI is written in Python. It's completely open sourced, and that is addressing the requirement of the operational teams that they want to customize the way they talk to the system. You can write your own CLI, you can write your own plugins, or you can even change or customize the CLI we have developed for you. So as you can see, SR Linux is unique. It's much more open. Focused on automation, of course, with SROS reliability and scalability. Now, on top of that, we have our Fabric Services platform. So Fabric Services platform is a toolkit to automate operations in large-scale data centers. And same as with SR Linux, we took a clean slate approach, which means we designed it from the ground up to meet the right architectural requirements. So our Fabric Services platform leverages Kubernetes to deliver you a cloud-native, containerized, microservices-based platform that is very open in the sense that you can plug in any of the well-known Kubernetes community tools into our Fabric Services platform. So the focus is again on scale and on openness, and that's very different from traditional fabric management systems that are often monolithic in their design and as a result very limited in scalability and very closed, right? Very, very hard to customize. Now, from a functional point of view, the Fabric Services platform delivers full automation of the entire lifecycle of a data center fabric. It has an intent-driven design and operations framework. It has a digital sandbox capability for network emulation, and it gives you a cloud-native way, an easy way to integrate Fabric Services platform into your customer-specific environment. Okay, let me just double-click on some of the aspects of FSP just to show you how this is different from current solutions that are out there on the market. Let's start with intent-driven design and operations. If you look at the Fabric Services platform, it basically allows you to define your fabric and your workloads as code in YAML files. And it will take that input, it's basically a declarative intent-driven system that will take that input to automate the operations of the entire lifecycle of that data center. What that effectively means is that you automate and simplify day zero operations where based on your input defined in simple YAML files, we will auto-generate the fabric design, we will auto-generate the cable maps, we will even auto-generate the configuration files for every switch in your data center environment. We also simplify day one operations because we will auto-discover new switches that get connected to the network, and using our ZTP implementation, we will make sure they get the right image, the right configuration file. We basically make sure that their configuration is aligned with the intent that you defined for that fabric. And we also simplify day 2 and day 2 plus operations because we will automate workload deployment on that fabric as well, so basically EVPN deployment. And we will continuously audit and monitor that fabric, and we will flag any intent deviations. If somebody goes in, makes a configuration change to the fabric that wasn't intended, we will notice, we will flag that, and we will provide closed loop resolution. What Fabric Services Platform does as well is it provides you a very scalable telemetry collection infrastructure and a flow analytics infrastructure with customizable visualization options as well. And within its operational pillar, it has a very powerful capability to basically link that telemetry data that you collect from the network with the intent you define for your fabric and your workloads. And that gives you very nice operational views that make it easy to engineer your network and easy to troubleshoot any problems in the network. Now, the second part of FSP that I just want to talk about is our digital sandbox capability. And that is a really unique and a very important capability of our Fabric Services Platform, because what I said at the beginning of my presentation is that one of the big challenges that web scalers are facing today is they need agility to implement changes very quickly, but they need tools to manage the risk of change. That's what our digital sandbox capability is all about. What this allows you to do is to create a digital twin of your production network. So we will discover your production network. We know the images being used, the configuration file, the state of every system, and we can create an exact digital replica using containerized SR Linux instances. And we network those together, and we can even surround them with traffic generators so you can test real traffic on that digital sandbox. And this goes a long way in managing the risk of change, because now you have a perfect lab environment, which is not a sample, but an exact replica of your production network at scale. And you also know that your digital sandbox is completely in sync from a configuration and a state perspective with the production network. So every change that you want to do, you can first play out on the digital sandbox. Configuration change, maybe you want to play around with a new feature, maybe you want to even do a software upgrade, you can do that first in the digital sandbox, and it will tell you exactly what the effect of that change is going to be when you do it later on your production network. Now, of course, our data center portfolio is also bringing to market a whole new set of data center routers and switches, of course, the hardware on which SR Linux runs. And as you can see, it's a very broad portfolio from day one. We have routers for super spine and spine deployment cases, and then, of course, leaves as well that face the compute nodes. It's a full portfolio. It's all based on merchant silicon, which meets the requirements of the data center space, and it nicely complements our FP4-based routers that we use for data center gateway and, of course, wide area networking applications. More about our hardware in the session from Jeff, where he will give an overview of all the new hardware developments we have done. Now, with all that combined, I think we bring to market a true third-generation data center solution, a full-stack solution which has leaf switches, spine switches, super spine switches, SR Linux on top of that as a new network operating system, and then Fabric Services Platform automating the operations within that data center and across multiple data centers. It's third generation because we bring, I think, the next level of scale and reliability with SROS. We bring the next level of automation. SR Linux has been designed from the ground up for model-driven management and very scalable telemetry, of course. And Fabric Services Platform automates the entire lifecycle of the data center fabric. And in terms of openness, this is fully open. Both Fabric Services Platform and SR Linux are modular, and you can plug in your own applications. And our SR Linux NetOps development kit for sure gives a much better application development experience. Now, there is a lot of interest from the industry, of course, in what we've developed, and I hope you're excited about this as well. We definitely look forward to working with you. This portfolio was co-developed with big web scalers, as I said, in the US, and some of them have already deployed this now in their production environment, of course. But during the development of this system, we've worked close together with cloud builders of any size. We worked with service providers, we worked with IXCs and colos, and we worked with large enterprises as well. And as you can see from those logos, quite a bit of good feedback and input for our Fabric portfolio. And I want to thank each and any one of them for contributing to the design of our portfolio. So reach out if you want to learn more. Let me now quickly move over to a completely different topic. And I want to talk about 5G. 5G is a mega trend in our industry, one of the biggest changes that is happening right now. And it's definitely gathering pace, right? There are big 5G deployments happening now in North America, but same in Asia Pacific, in China, in Korea, in Japan, and Europe and Latin America are now catching up very